know from our theories of gravity that if we can get enough matter together in one place, if we can produce these very high densities, then we can produce a black hole. But is there really any way that that can happen out in the universe? Or do black holes remain just a theoretical idea? To find out, I went to speak to Dr. James Miller-Jones, who's an expert in black holes from Curtin University. So, James, what are your research interests?
Hi, John. I research into black holes. So these are incredibly exciting and energetic objects. They were first theorized a couple of centuries ago and then fully described by Einstein's theory of relativity. But observational evidence was only forthcoming in about the 1960s, which turned them from a fairly abstract technical concept into a real observational reality.
So these objects were predicted by, for example, by Einstein's theories of gravity as these things that are so dense that even light can't escape. What evidence do we have that they really are there, and what would a black hole even look like? It's black, right?
As its name suggests, it is black, but we can see it when matter falls into it. So the matter then gets very, very hot. It's losing a lot of gravitational energy as it falls in towards the black hole, and that energy release is what we see when we look at these things. So although we can't see anything from the black hole itself, it has such an effect on its surroundings that we can actually observe them in certain situations. So one possible situation to observe them, and that's what I look at, is when the black hole is in orbit with another star. And if they're orbiting close enough to one another, gas from the other star can fall in towards the black holes. It gets hot enough that it can emit X-rays, which can be picked up by Earth-orbiting satellites. And we can use those to study the black hole and to find out its impact on its surroundings.
So we know that, or we have evidence that there are black holes orbiting very close to other stars, but how do we think the black hole actually formed?
So black holes form from the deaths of very massive stars. A star spends its lifetime burning nuclear fuel to prop itself up against gravity. When it runs out of fuel, it can't prop itself up anymore, and so it collapses inwards. If the center of the star, the core, is more than about 3 times the mass of the Sun, we don't know of anything that can stop that collapse. And so we think that collapse has to carry on indefinitely, creating an object that is so dense that not even light can escape. And that is the black hole.
Okay, so we have a really good physical model for how black holes could form, and we see X-rays and radio waves coming from this matter that's falling into the black hole. And what happens after that? Does it all just fall into the black hole, or is there some other processes that are going on?
So we can't say anything about the mass that actually falls into the black hole. That information is barred from us. We can't see inside the event horizon because the escape speed is faster than that of light. However, what we can see are the processes that go on as the matter falls in. As gas falls in, it spins around in a disk a little bit like water going around a plug hole, if you will. And that process twists up magnetic field lines, which can slingshot some of the particles outwards. And this can create very, very energetic beams of particles called jets. Those jets emit radio waves, which we can use to study the processes occurring around the black hole.
So do we know how these jets are shot out? Because it seems really strange to me that something falling into a black hole would suddenly be shot off at almost right angles to the way that it was travelling into the black hole.
There's a lot of work going on to understand exactly what is causing these jets to be accelerated. How do we launch them in the first place? They're seen throughout the universe. They're seen from the supermassive billion solar mass black holes at the centers of galaxies, and they're seen from these small black holes a few times the mass of the Sun that are orbiting around other stars. So we see them throughout the universe, but we still don't really understand quite how they work, and that's what my research is aiming to do.
Okay, what are the great prospects for us managing to unlock this puzzle which has been around for decades?
Obviously, as new technology comes online, we're able to make big advances in our understanding. So a couple of very exciting prospects in black hole research are the Square Kilometre Array, which is being built in South Africa and Western Australia, and also a very high resolution telescope called the Event Horizon Telescope. So the square kilometre array with its ultra high sensitivity will be able to detect pulsars that are orbiting around black holes. If we can do that, we can use this very exact clock that we have from the pulsar, this ticking as it spins around, to probe the space-time around a black hole and find out, was Einstein's description really correct? The other prospect that I mentioned, the Event Horizon Telescope, that aims to put together a high enough resolution telescope that we'll be able to see fine detail the size of my thumbnail on the moon. With that, we'll be able to actually image the black hole at our galactic center to actually see the shadow that it casts, the region from which no light is escaping. And that is an incredibly exciting prospect.
Well, it sounds really exciting what you're doing now, to see this, to be able to probe this incredibly extreme environment around a black hole and try and understand that. But I think you're right, to be able to actually see that picture of the black hole, this very extreme environment with a little black dot in the middle, would be really, really exciting. James, I really envy you. It sounds like you have a really exciting job, and thank you very much for coming to speak to us today.
Great pleasure, John.
So in spite of how exotic these objects may sound, black holes really do exist. We have very strong evidence for that. Also, in spite of the apparent weakness of the gravitational force, they're able to power the most energetic objects in the universe. And in spite of the name black hole, these are actually very, very bright objects because of what's going on around them. Through studying these objects, we're able to answer questions of fundamental physics which are very, very difficult to answer by doing experiments here on Earth.